Welcome to the chemistry lane. Today's topic is on electronic configuration 2. In the last video, we described the meaning of electronic configuration, but today's class we will be looking at orbitals and how to write the electronic configuration of some elements in form of orbitals. Atomic orbitals describe where an electron is likely to be found in an atom. Remember, electrons are found outside the nucleus of an atom and they move in an imaginary path. Types of orbitals. There are 4 different kinds of orbitals. These are S, P, D, F with different shapes and different numbers of electrons. The S subshells hold 2 electrons, P 6 electrons, D holds 10, while F takes 14 electrons. Now this is a table that shows the maximum electron of each orbitals. Each of them can take this maximum electron listed here. The next table shows us the number of orbitals in each shell we looked at in the last video. K shell being the first shell has 1s in its orbital. The L shell, which is the second, has 2s and 2p. M shell with the third shell has 3s, 3p, 3d, and N with shell number 4 has 4s, 4p, 4d, and 4f, and it goes on and on. Next is rules for assigning electron orbitals. There are 3 major rules that must be followed while filling electron in the orbitals. These are the Ohm's rule, Pauling exclusion principles, and the Hobsbawm principle. So we go with Ohm's rule. Ohm's rule states that in a degenerate orbital, electrons are filled singly before pairing. While Pauling exclusion principle states that no 2 electrons can have the same quantum numbers. As an orbital can contain maximum of 2 electrons, they must have opposing spins. Then we look at the third rule. Hobsbawm principle discusses how electrons fill the lowest energy orbital first and then move up to higher energy orbitals only after the lower energy has been filled up. Now these 3 rules will be put into practice, and one of them is this sequence of filling electrons, which is from the Hobsbawm principle that said electron in the lower energy is filled up. So in this format, we filled 1s, 2s, 2p, 3s, and they go on like that according to their energy level. The orbital diagram is a visual way to reconstruct the electron configuration by showing each of the separate orbitals and their spin. So this is an example of electron configuration. This is carbon with atomic number 6. So the 2 electrons goes to the first orbital, which is 1s. The second 2 goes to the s orbital, which is 2s. Remember, the s orbital cannot take more than 2. While the last 2 that will complete the 6th atomic number are filled singly according to Ohm's rule. For nitrogen with atomic number 7, the 2 electrons goes to the 1s orbital, the next 2 to the 2s, while the last 3 are filled singly according to Ohm's rule. If you check from the Pauling's exclusion, the 2 arrows are following opposite direction. One is going up while the other is going down, according to Ohm's rule that they must be in opposite spins. Oxygen with 8 electrons has 1s2, 2s2, 2p4. The last electron, after filling singly, is now being paired with the first orbital in the s block of the p electron, according to Ohm's rule. Pairing them immediately is an incorrect way of filling the electronic configuration of oxygen. Now this table shows the electronic configuration of other elements, beryllium with 4 electrons as 1s2, 2s2, white boron 1s2, 2s2 with 1 electron in the p orbital, carbon same with 2 electrons in the p orbital. Notice the p orbitals are filled singly, just like the correct way of writing the electronic configuration. Other examples are sodium, magnesium, aluminum, silicon with the electronic configuration. First filled with the energy in the lowest level, which is 1s, followed by 2s, 2p, then 3s orbitals. So to know how to do this, you need to practice more often. The more you practice, the more it gets stuck to the brain. Thank you for watching and see you in the next video. Don't forget to share, like, and follow us on TikTok, Facebook, YouTube, and Instagram at The Chemistry Lane. Bye for now.